Hello. So this is the fourth video in my series of videos about a Tesla solar panel project at my home here in South Florida. Um, the last video we left off with me attempting to negotiate with Tesla um, over some collaboration from them. Uh, Basically, I've had to downsize my grid-tied solar install to 11.76 kilowatts of panels, uh, just over 10 kilowatts of inverter capacity. But the reality is, I think 11.76 kilowatts of panels is not going to generate any more than maybe a peak of 9 kilowatts of power. So I had to downsize to that because of regulation in the state of Florida that requires you to carry liability insurance up to $1 million if you exceed those size limits. And what that means for me is that there's no way that I can be self-sufficient in terms of electricity with an installation of that size. I really need to be up at around 16 kilowatts of panels and 15 kilowatts of generation capacities from the inverters to achieve that. So my plan was to off-grid the balance of panels, an outstanding 4 or 5 or 6 kilowatts of panels, and to wire them into a pair of solar generators that I got called Bluetti EP500 Pros. And recognizing that that's not the business that Tesla is in, I did ask them for some level of help. And the levels of help I asked them for were, one, would you install the rails as part of the overall installation, so that I simply had to slap the panels on and wire them. Level two would be, would you also sell me the panels even though you're not going to install them? And of course, the jackpot would have been, hey, would you like to get into the off-grid solar installation business as well? Which I didn't think they would do, because they're very much into a cookie cutter projects where they are basically using boilerplate permits to apply for permission to go ahead. And so I kind of knew that wouldn't happen, but in fact, nothing happened. They won't do any of those things. And what slightly annoyed me in the response from them was a kind of slightly misleading statement to the effect that any solar installation in the state of Florida requires you to carry the $1 million of liability coverage. And I simply don't see that as being the case. That $1 million is all about risk to Florida Power and Light, their plant and personnel, when you're grid tied. So I kind of didn't like that as a way of excusing. I think simply, no, we're not in that business and we won't do that, would have been fine. So I basically said to Tesla, okay, then let's proceed. But clearly now we had a panel design for 16 kilowatts of panels, a total of 48. And now we're going to be dropping down to 34. So 14 panels are coming off. And so thinking that I want to do an off-grid installation in the future, I decided, well, what suits me? Where would I like to put my off-grid panels? And the first thing is, I would like to put them on the back of the house. The reason being is I'm not entirely sure that I would pull a permit. And I live in a neighborhood with a homeowners association and some rather nosy neighbors. The other thinking for me was I might like to install my panels in a part of my house where I have easy access to the attic. So I have told them to take the panels off a part where I can stand up in my attic, because it's, I don't have a vaulted ceiling in there, so I've got this full height. And some panels that I had asked them to take off the front for aesthetic reasons, I've just said put them back in order to clear this space for me to work in the future. And since then, I've been looking at what it would take for me to do my own off-grid install. The first thing I've been looking at is the rail systems. And very specifically the hardware that you use to attach rails to a tile roof. My tiles are what is called S tiles. They're concrete tiles. There's two kinds of, well, I think there's two kinds of S tiles, but actually it may be that there are W tiles and S tiles, and I have S tiles. And the manufacturers of rails systems offer products called tile hooks. And the idea is that those reach under a tile to the deck and provide you with a flange or somewhere where you can drive lag bolts through the deck into the underlying rafter. And there are different kinds, some of which offer greater adjustability. The manufacturers who make the better ones warn you against the dangers of using cheaper ones, and I'm certainly not going to be buying anything cheap if I'm going to do it myself. You don't save money on the hardware when you're doing it yourself. And there are a few kind of options that you can get. You can get a flashing, which is basically a tile-shaped piece of aluminum. So remembering that these tiles where you're putting the hooks are going to be covered by the solar panels. It doesn't really matter whether there's actually a tile there or not. So you can get these tile-shaped aluminum flashings to put there in place of the tile. And you can also get some flashings which will sit under the tile, but which provide a kind of an additional protective barrier, a kind of a dam around the roof penetration point. So basically something that you're going to stick down with sealant and then put some more sealant and some fiber tape around, so that any water which is running down the deck isn't going to run towards the hole that you have made. You'll try and direct most of it round. So anyway, I've been looking at that and thinking about what I would do. I mean, I believe the wind loading requirements. You get information on the websites of these racking system manufacturers. They basically offer you an app which allows you to punch in lots of parameters about what you need in terms of snow load and wind load, and from there it will determine the spacing that you need on your on these tile hooks that will provide support or mounting points for the rails. I believe I need I think I might need them every 2 feet or 4 feet, but I'm going to be very conservative. The last thing I want to do is see my roof ripped off with solar panels because I put solar panels on it, and think that because I saved myself $100, $200, $300 on installation, I've kind of wrecked my house. So I'm not going to do that. So been looking at that. I also managed to track down the actual panels that Tesla provide. They are Hanwha, which is HANWHA Q solar panels, and they're actually not all that expensive. The 340 watt model that they are proposing to install at my house, I managed to find those in the low 200s once you start buying a reasonable quantity of them and you start knocking down the shipment. I think it was from a1solar.com. But then I ran into some complications that have me stumped for now. Basically, I'm getting these two Bluetti EP500 Pros, each of which has two MPPT charge controllers. And the specs for those charge controllers is that they will generate a maximum of 1200 watts each of power into the batteries of the solar generators. But then they have specifications regarding the maximum current and the voltage range supported for any panel string that's connected into them. And the Bluetti EP500 and 500 Pro are new products which are actually on Kickstarter, so they're not even in production yet. And a parameter of any solar controller or charge controller is there's the maximum operating voltage range, and then there is the absolute maximum voltage that can be put across the solar input terminals of the port. And you basically have to reconcile that with your panel string. So each panel, if you did just a pure series string, each panel in that string has what's called a VOC, voltage open circuit, and you have to add those together to calculate what the maximum open circuit voltage could be on the panels, which I believe happens when it's a sunny day, but power is not being drawn from them. And then you have to add in another consideration. Apparently, when the temperature drops, that open circuit voltage goes up, and there's this like thermal coefficient which allows you to calculate the absolute maximum value that this could ever reach on a given panel on the coldest day that could occur in your part of the country. So I estimated in South Florida 0 degrees centigrade, and basically that's got if I had a string of 4, which is what I wanted to do, I would potentially be up at, I think it might have been something like 180 volts, and that's probably too much. The maximum operating voltage is 145 volts DC. So I'm watching that space, trying to decide what to do. Now, the other alternative you have is you can parallel your panels, but when you parallel them, so if you had 4 panels and you parallel them, you half the voltages, but you double the current. So the current figure typical for this kind of solar panel is around 10 amps, and the maximum current on this MPPT input is 20 amps. So that doesn't seem to be working out either. Doesn't help, of course, that this is all new to me and I'm pretty ignorant. So I'm hoping that we'll see more guidance come from the manufacturers of the solar generators, because my application has to be a fairly standard application that many people will want to buy these for roof-mounted glass high-performance solar panels. So one hopes that that they will be able to accept a panel string capacity which allows you to drive them up to their full 1200 watts. And that normally would be a total capacity of beyond the 1200 watts, because those panel capacities, like for example 340 watts, that panel is never going to get near that. Maybe in Florida on the sunniest day in the middle of summer, it's maybe going to get over 300 if you're lucky, So that's where I am. I rambled pretty long already. And I don't have too many specifics to ramble about at the moment. Kind of cheesed with Tesla, but I can't really let that get in the way of the fact that they are cheap. I am Scottish after all. So I just think that they allowed my expectations to reach a certain height on the basis of getting my full 16 kilowatts grid tied. And we could have dealt with that issue of liability insurance at an earlier point in the overall process. And I also feel that they could have come up with some creative solutions to work around that. I mean, they could have offered insurance, for example, because the reality is I don't think if they offered an insurance policy specific to liability in relation to FPNL or your utility, I don't think anyone's ever going to be paying out on that policy, because the equipment simply doesn't allow you to do what FPNL claim to be worried about you doing. So disappointed with Tesla on that front. But then I'm not a Tesla fanboy, so I had no illusions about Tesla prior to getting into this. Okay, I think that'll do, and I'll see you next time when we have some developments.